Hey everyone, welcome back to my channel. So today I have a guest who has been building software longer than most of the frameworks we use today have ever existed. He has been a software developer since 1997. That's almost 3 decades of building, breaking, and shipping software. He's a Java champion, an author, podcaster. And if you have been into distributed systems and microservices, many of you might have probably heard of the 12-factor app methodology. He was a contributor to that also. Yeah, this person has genuinely moved Java forward. And if you have been in the Java ecosystem, you would have probably come across his work, even if you didn't realize it. Here is James Ward with us. Welcome, James.
Hey, good to be here. That was quite the intro. Wow. Makes me feel old. I've done a lot of things.
Not really. I think here's what makes this conversation really timely because James is deep in Java and AI space right now. And he has been one of the people actively shaping how Java developers think about AI engineering, which is exactly what we are going to dig into today. So, James, welcome. Really glad to have you.
Thanks for having me. Yeah, it's fun to be here in Bangalore, nonetheless, for the GIDS conference. So, yeah, super fun to be in person with you.
Before we dive more into AI agents, agentic systems, let me ask you first about this entire journey that we have observed, right? Like back in 60s when we had this entire evolution of AI, artificial intelligence. So we were talking about AI ML, then we were talking about deep learning. Slowly we moved into generative AI, LLMs, and now the world of agents. So it has been quite a journey over the past few decades. So now that we are seeing this journey, it has evolved from the world of AI ML and then LLMs, and now we have agents. What is your take on this?
Yeah, it's been fun to be part of. I first started doing AI stuff maybe 7 years ago or so. So before kind of the LLMs took off. And I've always been a math nerd, so it's into just the ideas behind how that stuff actually works. But I think this is by far the most interesting time with AI because what we finally figured out is how to have these large language models, these generative models that can do all sorts of things. They can describe the contents of an image. They can translate languages. They can turn natural language into programming language or turn programming language into natural language. Like there's these knowledgeable translators and that are incredibly powerful. And that's awesome. But really what has been unlocked just over about the last year is really the ability to turn those models into things that are connected to our business data, our business processes, the tools that we use, the things that we need access to. And so being able to link those two together has opened up so many amazing opportunities. So, now at this point, it just seems like all of us are generally using these tools all the time because it's not that they can just write poetry like they used to be able to do. Now they can actually help me be more efficient with my daily work, whether that's writing code or creating specifications or reading my email and responding to the easy ones, or so many different use cases now that we have been able to bring these two worlds together of the LLMs, that are those knowledgeable translators, with tools and data and business systems. And that's where things have just gotten super interesting in the last year.
Yeah, that's amazing. I really liked the word that you used, that LLMs are called the knowledgeable translators now. And where do you think, we have been talking about a lot about traditional ML in the 90s, and then there were deep learning libraries, and Java also has certain deep learning libraries as well. But then there is a space for traditional ML, and then there is a space now for generative AI and LLMs. And I believe that there are two different things. One is the capability of building models, and second, for people who have been working on the application layer, it's about integrating models and going towards enterprise AI adoption. So I think for Java developers, what is that first fundamental messaging that you would want to give to the developers out there who are often getting confused about two different things and the line is getting blurry?
Yeah, I think it's good that you make the distinction because in the world of creating the AI models, Python has been the predominant tool of data science and the ability to come up with the algorithms and do all the model creation side of things. And because it was really founding that whole era of things, a lot of people then, I think, assume that you should also use Python for the agentic application side of things. But if you look at what those agentic applications generally are, they're usually a bunch of integrations. And Java has been the place where we build enterprise-grade business system integrations that power the world. And this has been by far the predominant choice for those types of applications. And so what a great time to be able to build AI applications that are mostly about integrating data and integrating systems with the LLMs and be able to do that in Java. So yeah, I think it's a fantastic time to be a Java developers because every business is looking at, okay, where can we use AI to, whether it's increase productivity or be able to accomplish things that maybe were too hard or too tedious to do before. And now we can build these agents very quickly that are tied into our business processes and business systems and do it in secure ways. And so, yeah, I mean, this is just a really prime time to be a Java developer, because we know how to build these integrations. We know how to do it with reliability, with scalability, with security, all the LEDs that are important. We've been doing this for decades now. And so yeah, it's a fun time.
Absolutely. Totally agreed with you, James. I think integration is key over here. And like you rightly mentioned, that as Java developers, this has been our bread and butter for decades, that we have been always at the middle of integration, right? And now my next question to you is that we have been talking about generative AI, and then there is LLMs. And slowly now we are talking more about AI agents, multi-agents, and agentic systems. So again, this arc has kind of deepened, that now we have moved from just calling that LLM with a prompt, getting a response, to now building agents and slowly building agentic systems, where the systems are now predominantly being autonomous in nature and taking the actions. So now my question to you is, as Java developers who are now going to, let's say, architect an AI agent, it is very important for developers to also understand that when do they actually need to build an agent, or when do they actually need to maybe stick to, let's say, traditional ML models. And like, what is that point where you can say, developers should actually be confident, okay, I need an agent for this, or we do not need an agent? Because as developers, we are always in the intersection of writing business logic. There are business problems to solve, but it's always about why are you doing what you're doing. So what is your perspective on that?
Yeah, I think first it's important to clarify what we mean by an agent. And so the way that I define that is that we've got the LLM as this knowledgeable translator that can, go from one input type to an output type and do that in a predictive way. So it's going to use, not 100% of, it's not going to do the same thing 100% of the time intentionally. And so, so how do we take that and then combine it with our business logic and allow it to accomplish a goal? And so when we do this, we put it into a loop. And so we take our calls to the LLM, we take the tools and integrations that thing can work with, and we run it in a loop until it has completed what the user has asked it to do. And the user could be, somebody in a chat interface, or it could be a business process that I want automated in this way. And so in that case, I've come up with the prompt, and I may be triggering it based on some event, new record added to a system, whatever it may be. And so that is the heart of an agent. It's just this loop around LLM and what we call tool calling, the ability to talk to external systems. Yeah. And then another core piece of the agent architecture is memory, the ability to in that loop know on that second time around, the third time around, the important things that were said went back and forth on the first time and the second time. And so being able to store that and be able to do that efficiently in the right way, preserving the right things in memory, is another key component of this agent architecture. So we've got the agent, and now this thing is connected to our business systems, potentially through MCP. And MCP is a great protocol for doing that wiring between our agent, the LLM, and external systems. And so great, now we've got our kind of basic architecture for an agent. And then what do you want that agent to do? It really is up to your business. Where does your business see the need for this knowledgeable translator wired to business logic, business data, the ability to act on the outside world or get information from the outside world, connected to that LLM, that model? And so there are so many different opportunities for where that can be used. But developers are generally familiar with the code assistance as being one of the ways that we can apply an agentic loop to our work, which is taking thoughts in our head basically and turning them into code that gets executed on a computer. So there's the knowledgeable translator that can take my thoughts or my words that I've typed in and turn them into code. Or sometimes I highlight code and say, explain this. And so then it's going the other direction, from the knowledgeable translator from that code to natural language. And so sometimes I give it an image and say, there's a bug on the screen of this web app I just created. And then it's a knowledgeable translator from what's in the image to ideas to the code that needs to change. And all this is in a loop. So it's got the tools to be able to read files and potentially execute programs on my system and call MCP servers. So I think that's something that most developers are very familiar with now, is this agentic loop applied to programming. But any business has many different places that you can apply that same agent loop to and connect it to your business systems, your business data for your users. Maybe those are your employees, maybe they're end customers, maybe they're just autonomous jobs that need to happen and can be empowered with AI. So yeah, I think it's a really fun time to be building this stuff, because there just is endless things. The list of things I want to build in my head is forever long, and working through it, but it's lots of opportunities.
Yeah, I think a fun time to convert all those side projects that we have in our backlog to now actually action on them and get to building. And I really like the way that you basically said that agents are nothing but LLMs or models with to which we are providing the tools and the memory, and then they're running in a loop. So basically the keywords or agents are nothing but models with tools which are running in a loop. And then agents also have this certain framework, right, which I define like RPAG framework, where they kind of reason and then they plan and then they act according to a given goal. So yeah, tying back to the question that, of course, if there is a business need, there's a business problem, which is definitely the goal. So the agents need to apply that RPAG framework and use the tools and the memory and run it in a loop. So that is where essentially as developers should be able to take a call on when to really use an agent. So yeah, this is really, really amazing. So now that we have talked about where we have come from, where we are today, and let us also talk about where we are heading. So it is very important for Java developers to understand what is there forward. So on my channel, I have been talking about a lot about Java and AI space, and I recently did a video around the AI engineering learning path that Java, Spring Boot developers or backend developers need to have, sort of like a mind map where we have certain components. Now, I also have talked about the very recent website that you have worked on, which is aiforjvm.com, which I consider like the one-stop solution for all that you need to know about what is happening in the Java and AI space. And it will also give you all the recent announcements and FAQs. So yeah, James, would you like to talk more about aiforjvm.com and of course the learning path that you are seeing for the Java developers going forward?
Yeah, it's actually surprisingly a vast space. And I think that most people don't realize just how much is going on in the world of AI for Java and Kotlin, and it's a lot. And so that's why I put together that website, was to give people just an overview of, okay, here's all the different agent frameworks that are available in Java, because there's a bunch now. Here's all the things for doing inference and inference related things in the world of Java. There's a bunch of new stuff happening in the JVM that actually is going to make being able to do some of the core AI model creation, model inference stuff actually viable in the JVM, which is pretty wild. And so that's documented there. There's resources for developers who are building with Java and using AI code assistants. And so there's like agent skills and MCP servers and that sort of thing listed there. There's a list of a number of people that are relevant in the world of Java AI stuff. There's some FAQs, and then just a bunch of kind of general resources around Java and AI. So yeah, so hopefully it's like you said, like the kind of the landscape of the world of Java and Kotlin AI things. And so yeah, there's a lot to dive into. I think in terms of where people should start is probably with what they're already familiar with and using. And so while that ecosystem is already quite vast, if you're doing Spring, then Spring AI is going to be the easiest way into the world of building AI agents in Java. If you're doing Kotlin, there's Koog. If you're doing Quarkus, there's LangChain4j and some great integration there. And so really, I think for each kind of ecosystem, sub-ecosystem of the world of Java, there's a natural choice there. And then there's some more advanced things that you can get to. So there's things like Embabel, which is created by Rod Johnson, the creator of Spring Framework. And he built a agent framework that is doing some really kind of next level things beyond what any other agent framework has put together. He's really thinking about how do we set up these agents to solve business problems in ways that are going to actually work. A lot of AI projects have failed in the past, and it's primarily because their patterns maybe weren't oriented to how businesses actually solve problems. And so Rod has taken a fresh look at things like RAG and tool search and how he does MCP things, how he's doing memory, and he's really like redefined how that should work well in an enterprise space. So definitely worth looking into Embabel. And so yeah, and then there's just so many other things there. There's like the Java MCP SDK, and just go check out the website and dive in. But I think start with what you're most familiar with and what is the kind of easiest path to AI from where you're at.
Yeah, absolutely. I think you mentioned something very important, that stick to your core strengths. So if you are a Java and Spring developer, of course, Spring AI and LangChain 4J are the most popular libraries or frameworks that we are using today for AI development. But I think three very important things that you mentioned is, so if you're a Java or a Spring Boot developer, of course, stick to Spring AI. That will be the easiest way for you to get into enterprise AI adoption. Number two, if you are a Kotlin developer, Koog is the closest library that you can get onboarded with.
That one's created by JetBrains, and so the folks behind Kotlin have created their AI framework, agent framework, and Koog's actually great. It's got a lot of really good ideas in it. The programming model is nice and concise, like usual with Kotlin, and they even have a Spring Boot integration now, and so you can even do Koog with Spring. And so yeah, if you're doing Kotlin, it's an interesting one.
Yeah, that's even amazing. Now you have got more options as Spring Boot developers. And third, if you have been into Quarkus, then that is where LangChain 4J will be again the closest framework for you to work with. I think one of the very recurring questions that I have been getting from the developers on the channel is when to use which framework, or what are the trade-offs between using frameworks. So I think the absolutely fundamental answer to this is stick to the framework which is closest to the stack that you have been working on. And also, James, when we are talking about this particular learning path, and where do, as Java developers, where do we start from, right? So while going through the website, I also came across something which I did not know much about, and that was around the inference engines, specifically the deep learning libraries for Java, because that is a space where mostly Python developers have been dominating. And as Java developers, I think there's a lot of lack of awareness around what is happening in the inference engine space around Java. So because as Java developers, again, we are more at the intersection of the application layer and the data layer, where we're building applications, integrating business logic. Now, when we also talked about that, Java developers do not essentially need to build models, but then we also have these inference engines which give the capabilities to the Java developers, right? So now, if anyone is really interested to venture into that space, what is your what would you suggest to those developers, or what is actually happening in that particular space? It's pretty interesting, I guess.
Yeah, I mean, I think there is a whole segment of developers that is more interested in the model side of things than the agentic, building agent side of things. I'm on the building agent side of things. And so I have not done anything with the inference side of things and the model side. And so so I should dive into it at some point. There is many resources on AI4JVM.com around the inference and model side of things. And I don't think I've ever really looked into or used any of those that are on that part of the website, but there is a whole giant community of people that want to do that kind of stuff on the JVM, and it's becoming more and more viable. There's some great projects there. So yes, I think people should dive in and then teach me all about those things. So
definitely, I think there's a lot to catch up with. I mean, as you said initially, also it's a vast ecosystem, and I think it is growing day by day. I think for all of us, it's very hard for all of us to catch up with all the things. I think the very important foundation that we have created with this website is to first give the tools, the technologies, the announcement that as Java or JVM developers, they need to know first, so that in one portal they have all the things available, and then let people, the developers, play around with whatever they want to. I think that is the one fundamental issue, is something this portal is definitely going to solve. And I really like the announcement section of that particular website, where we are also keeping up with what is happening around this Java and AI space. And James, I also was thinking that you mentioned around Embabel, which was created by Rod Johnson, who is the creator of the Spring framework. While we are talking about Spring AI, and then the creator of Spring himself created another framework on top of it, which has a certain paradigm around the goal-oriented action program, which is called GOAP, right? Yeah. So now I think there can also be a question in the community that, okay, we have Spring AI, and now on top of that, we have Embabel, which is again built on top of Spring AI itself and by the creator of the framework. So there can be again a thought around when to use Spring AI, or maybe when to use Embabel, or maybe a combination of both. So what are your thoughts on that?
Yeah, I think for me, they do live at different abstraction levels. And so so Spring AI is going to be the most kind of direct mapping to what a Spring developer knows how to do. It's very fluid with the Spring ecosystem. Embabel is a whole agent framework that, while it's built today on top of Spring, it's this whole abstraction, and so it does fit well in the world of Spring, but it's really a totally different thing. And so it's great. I think there's a lot of really good stuff in Embabel, and if you really want to dive deep into solving business, concrete business problems with a very kind of robust and probably the best option that exists anywhere for building enterprise grade agents, Embabel is going to be your choice. But there is a learning curve to it. Whereas with Spring AI, you just drop in and it's like, cool, I got a chat prompt. I'm going to hook MCP tools to it. And like, that's like 3 lines of code, it's so I think, whereas in Babel, you can do things pretty darn concisely, but there is a whole kind of mental model around in Babel and like how you actually architect things in that world. But I don't know, try them both and let me know what you find.
Definitely, I think up for the community, open for the community to try both of them. I think it's important to understand that if you're already in the ecosystem, it's more like a brownfield project. Probably using Spring AI and doing integrations using Spring AI into your existing code base makes more sense. However, if it is a greenfield project and you're trying something out completely from scratch, and that is where probably Embabel could be a better fit, because it's more a very niche abstraction which works on the agent frameworks. And I think Java developers love working with abstractions, right? So I think that would be another place for them to try out for something, a business problem which is very much rooted in that particular framework. So yeah, I think Spring and Java developers, they should be very clear about the thing that if it's a greenfield project, do try out Embabel. But if it is your enterprise system, which is running in production for a couple of years, it makes more sense to integrate Spring AI as the framework over there.
And you can use Embabel with Spring, and so you could mix and match those things. One of the core value propositions of Embabel is being able to bring your domain model into the context of your agent in ways that make sense. And so even in Brownfield, it makes sense to use Embabel when you have existing like JPA entities and you've got your like business data and business logic right there, and Embabel makes it easy to like tie those things together. Rod coined something called domain integrated context engineering, which is this idea of context being so related to the domain objects, the actual domain data of your business systems. And so a key piece of what he's enabling is bringing that enterprise data into the context of the agent. And so yeah, I think it for me, it's like which level of abstraction makes the most sense for you. Do you want something that's higher abstraction for really targeted at these like kind of enterprise domain integrated things, or do you want to just have kind of the building blocks that then you can put together and maybe get to a similar place, but have to do more work to assemble all the pieces together?
Yeah, absolutely. And talking of building blocks, we have been hearing a lot of buzz and implementation around model context protocol. Now, as Java developers who have been playing around with REST APIs, HTTP endpoints, and now we have MCP in the world of AI agents. So just wanted to understand that all of this buzz around MCP is already there, which is all right, but what does it actually mean for Java developers? Where does MCP actually have a role to play when it comes to enterprise AI adoption, which is being done by the Java developers or the Spring developers? What does this protocol actually mean for us?
Yeah, it's a good question, because MCP's only been out for almost a year and a half now, so it still is pretty new in terms of timescale and AI timescale. It feels like it's ancient, and so people proclaim that MCP is dead because it's been around for so long in AI timescale. But MCP is a great way to connect our LLMs and our agents to our external business data and business processes. And you can do this in two different primary transports. There's standard IO, and that's where most developers have experienced MCP. Is they run an MCP server on their machine, it forks the process, and then it's talking to some other system, packaged logic to talk to Postgres, for example. And that's a fine way to use MCP, and lots of Java developers will and should use MCP in that way. Where and I even created javadocs.dev, the MCP server there that allows your agent to get Java docs and pull things out of Maven Central for you. And so I think there is useful MCP servers for local development. But where I see the really kind of most interesting places to use MCP is actually on that like enterprise integration side of things, where I've got my enterprise agent, it's accomplishing some goal, whether it's customer support or managing some resource for me or whatever it may be. I need that to be integrated with my business systems, and I potentially need it to be integrated with other third-party business systems. And so whether it's Salesforce or Asana or whatever, you can provide those integrations to your agent just by plugging the MCP server into your agent. And in Spring AI, this is one line of code to do this. It is trivial to be able to take some massive amazing thing like Salesforce's MCP server and plug that into your agent in one line of code. Like it's like the ability to now wire together these pieces is unlike anything ever. You know, we used to have, you know, SOAP protocols and, you know, all these different message buses and all these things. And now our super intelligent AI agent can talk to whatever business system exists. Like it is such an amazing time for these integrations. And so MCP is, you know, fundamental to how we build these integrations between our agents and external systems, and it has been used a lot in the space of developer tools and developer AI code assistants. But as I said, that's not for me the most interesting use of it. But it's great there. It has been in some ways people that have used it for that local knowledge kind of use case. Now there's agent skills, which is an alternative to MCP. Well, not really an alternative. It's a complement to MCP. But now some of those things were initially built on MCP are now being built in agent tools. And so now there's this weird like Venn diagram of when should I use MCP and when should I use agent skills and what should go where. So for me, there's some good general guidance to those sorts of things, but it is a complex space that's evolving quickly. MCP is here to stay. It's really a critical piece of infrastructure in lots of ways. But yeah, that's kind of our overview.
Yeah, I think this is very important because I was seeing a couple of videos where they have blatantly put out that MCP is dead. However, we do see a lot of applications now being built with that MCP server, MCP clients. And very interesting thing is that I think as Java developers, we have always been good at integration, like we were talking about, right? Now, calling external APIs has been something which we have been doing. Now, connecting to another MCP server, like you said, based on a certain use case, is something like maybe just a couple of lines of code away. So it is again the integration story. It's again calling external APIs, but this time it's a different protocol. I think we're using JSON RPC for that, the different ways to handle the response. But essentially, at the very core of it, it's basically calling an external third-party API and integrating the response of that according to whatever the business domain that you're working with. And that is the reason why, as you said, MCP is of course here to stay, and of course here for more and more integrations for the AI applications that we are going to build, right?
Yeah, and one of the key things about MCP that is, I think, very important is that it has authentication built into the actual protocol, the spec. And so this means that when an agent calls an MCP server, if the MCP server has decided to, it can actually enable authenticating those requests and knowing user identity on the MCP side of things. So you can actually propagate user identity through from the agent to the MCP calls so that then you can maintain data security. Like you don't want, you have to know who your user is so that then you can only allow a query to get the things that they have access to.
Yeah.
And so MCP with its auth support makes that an easy thing to do, which is great.
Yeah, I mean, when we talk more about production readiness, I think a very important part of that has always been security. And now that we have the authentication layer, which is available and possible to do with the MCP, this becomes a very critical pillar when we actually talk about not just making a demo project, but it's more about building production ready AI agents in which security is going to be like the non-negotiable. So definitely that is the reason we should definitely go deeper into the protocol and start integrating that into the applications.
Yeah.
So James, we have talked about MCP. And there's one thing that now that we are giving AI agents the capability to fetch data, to do this calls, do this particular actions. And then there was this thing around having tools. So now MCP, when we are talking about MCP, are we saying that this is the next step? Like instead of having too many tools in your application, MCP has been kind of trying to abstract away this, or are tools also here to stay? So basically, what is the distinction between when should a developer who's building an agent have tools exposed in their particular application, or when they should actually have multiple MCP servers connected to their application? So what is the distinction between them, when to use which one?
Yeah, it's a good question. So as we've given our agents more and more tools, and that can be through MCP servers and through like local tools, that you can go either way or both ways when you add tools. As an example, you probably don't want to use an MCP server to provide like the current date and time or something to the agent, but you can have a tool that provides date and time, and so and just a local tool, or maybe you put that right into the system prompt or something. There's a few different ways to do that, but there's good use cases for both. And so I think the question that has been coming up a lot lately is, how do I, with all these tools that I'm providing, deal with a few challenges of having lots of tools? The first challenge is with as we give more tools to the LLM, it makes it harder for the LLM to reason about which tool to call when, because the semantics between tool A and tool B may be so similar that it then gets hard to decide which one is actually the right tool to call here. So that's one challenge with lots of tools. The other one is that there is metadata overhead to MCP. You have the descriptions, you have of each tool, you have the input schemas, and then you optionally have output schemas. And on every call to the LLM, which can happen a lot, you have to send all of that metadata about the tools, or you don't have to, which is what we realized initially when we started building all this stuff. We were naive and just like, yeah, let's just send everything and that's fine. But as we got more sophisticated and added a lot more tools, we realized like hey, it's pretty wasteful to spend all these tokens on all this metadata over to the LLM. So then the question arose like, okay, how do we actually address this problem when we have a lot of tools? And so a few approaches that have come up around this. One is that you can actually do semantic search on your tool set and then match the tool to what semantically from the user prompt is the most relevant tool, and then only provide those. And so that's one way to reduce the tool set that gets provided on a given LLM call. Another way is to reduce the number of tools you have at kind of subsections of an agent. So in agent orchestration, you break the typical kind of problem into steps that can be workflowed, orchestrated together. And what you want to do in that case is give each kind of section or sub-agent or whatever you want to call it, some sub-piece of this workflow, give it as few tools as possible to accomplish its goal. And so that is like tool grouping or just breaking down the problem into pieces and assigning fewer tools to each particular piece. So that's one approach. There's another approach which Embabel created, Rod and the Embabel team created, which is the ability to do what's called unfolding tools. And unfolding tools kind of create a hierarchy of tools, and then as the LLM decides, okay, now I need this tool, now I need this tool, it can kind of traverse down this hierarchy and unfold. And so yeah, just another approach. So there's a few different ways that we've been able to tackle the challenges of having lots of tools, and I'm sure we'll discover more. There's already like MCP gateways, which do some of this stuff for you, where you point your agent to the gateway, and then the gateway is helping you do these things, and then has the actual MCP servers underneath it. There's lots of different MCP gateway things out there now. So yeah, lots of different approaches to tackle the challenges, but none of these challenges are reasons to throw out MCP. It still is great, and lots of good things that you can build with it today. And so and always emerging new ways to address the challenges that we've uncovered by actually using the technology.
Yeah, I think the baseline for developers is, firstly, like you pointed out, that when we have tools, or maybe too many tools, the number one problem has been increased resource consumption or the token usage, that for unnecessarily we are calling that particular tools for doing something which could be abstracted away in some server and be used. And the second is, when we have too many tools in the application, there was also this report which I was reading, that if there are 30 tool calls, somebody created an application and now the agent is hallucinating, that they are not able to either invoke the correct tool, or they are not able to invoke the correct order in which they should be calling the tools.
Yeah.
So I think primarily two reasons why not having too many tool calls is very important in your application is for preventing the token usage, the consumption. We of course need to be cost efficient, or rather token efficient. And second is to prevent the hallucinations. And very important point which we also as developers need to keep in mind is, expose the tools in the applications only when you need it. Like for example, for date and time, don't import another MCP server which is just going to calculate the date and time. It absolutely makes no sense over there. I think that is very important for us to understand the distinctions about when to use tools, or when too many tools are actually not good for the application.
Yeah.
And
one quick side note on this. So one of the things I see when people criticize MCP, and they say it uses too many tokens, the one of the examples I've seen for them to support this is they say, okay, let's say that I have an MCP server that exposes a tool which is get customer, but then over on the agent side, I have a list of customers, like customer IDs, and I need to go fetch details for each of those customers. And if my MCP tool only exposes the ability to get one customer at a time, then I'm just going back and forth, LLM, MCP call, LLM, MCP call for each customer. You get into this loop. And of course, that's like, the rational thing for the LLM to do at that point. But they point to that and say, oh, we're wasting all these tokens because we're calling this thing multiple times.
Yeah.
And what they often miss in this conversation is you could just have an MCP tool that takes a list of customers and gets all of them in one shot, right?
Yeah.
And so part of this is being able to do some observability around how your MCP servers are actually being used, and then tune the tools that are exposed to the ways that the MCP wants to, or the agent wants to use them. And so you can discover, in one turn with an LLM or with a agent, so I'm going to try to get to accomplish my goal. In one of those loops, I called my MCP server the same thing 100 times. Like, let me just create a new tool that it makes it so I only have to call it once. Like some of this stuff is just easy optimization where we can use observability to solve the problem.
Yeah, I think really good point. I think latency and cost, there has always been a trade-off. Like in order to, now you're trying to save the tokens, but for that you are increasing the latency of the application by doing multiple hops between the server, like you rightly mentioned. So I think that is where, when we talk of architecting an AI agent, it is more about thinking in terms of systems thinking or system design level thinking, that what is actually going to increase the latency, or if it is actually decreasing the latency, but at the cost of what. So I think that is a very critical questions which developers need to think, rather than blindly integrating an MCP server, or rather than blindly adding a tool to the application. So I think it is very important distinction and a judgment level or a systems thinking level call which developers need to make today. And the second point that I want to highlight, that you mentioned that when tools, like too many tools is like too much for the application, and you mentioned 3 different approaches, which is very interesting for me, that I learned that one is, you mentioned semantic search across the tools, where we are actually just as semantics, meaning the meaning out of it. So what is the meaning of that tool? So on the basis of the meaning, the semantics of that tool, we are going to load the context accordingly. It's definitely going to be not, instead of loading all the 100 tools, you are loading just the query or the prompt what has been asked. According to that, what is a relevant tool? So being again tool efficient. So we are going to load that. The second one, which you also mentioned around
the unfolding tools,
that is the second way of doing.
Yep.
And the third way, which you mentioned, was around,
I think I talked about tool grouping and breaking out
tool grouping. Yes.
Yeah, breaking out your agent into multiple sub pieces, and then giving as few tools or a tool group to each individual piece, instead of having a universal list that gets applied kind of everywhere. So yeah, anytime you can kind of break something into a workflow and have multiple steps with limited MCP servers.
So right now, does Spring AI support both this semantic search and this chunking or this grouping of the tools? Do we have the code support for implementing these two? Because I think this is a very important enterprise problem also which is arising, that there are too many tools, but they either would want to maybe do a tool grouping based on the context or the domain requirement, or they would want to do semantic search. So do we have the support or the SDKs available for that?
Yeah, so there is the core Spring AI project, and then there's Spring AI community. And Spring AI community is where a lot of the things that are a little more experimental, like maybe we haven't fully decided what the right shape of the API should be, is. And so in the Spring AI community, there's a project called Agent Utils. And Agent Utils has a bunch of stuff in it, but one of the pieces in it is Tool Search Tool. And Tool Search Tool is a tool that searches for tools, and so it does that semantic search of the tools and then provides those to the next call of the LLM instead of just the tool search tool. So by default, you provide just the tool search tool, and then the LLM can search for more tools, and then those go into the next call. So that's how we do semantic search with Spring AI. And then on the tool grouping side, the way that we do that in Spring AI is we have the chat client, which is our interface to our LLM, and we can give it tools that are available to it. And so those tools are available on a specific instance of the chat client. But likely in a more complex application with Spring AI, you're going to have multiple chat clients, and each of those would likely have different tools, different what we call advisors, different RAG systems, different memory systems maybe. And so you're going to have a chat client for a specific piece of a workflow or a specific part of the overall agentic system, and that will have its own tools assigned to it. So that's how we do it in Spring AI.
Yeah, I think that would give a lot of opportunity to build systems or other integrate tool search tool or things like grouping. So I think it's absolutely a great way. So Spring AI community project is the one, but beware of one thing, that it's still in an experimentation phase, right? And it may not be production ready. So I think that is something which developers need to keep in mind when they're integrating it.
Yeah, I don't know what disclaimers they put on it. I think it's more about not ensuring backwards compatibility. Things that are core Spring things, they very rarely break backwards compatibility on.
Yeah.
And so while it may not be necessarily experimental, I think the things that are in Spring AI community are not necessarily guaranteed to not have breaking changes. And I think that's kind of the core reason why it's still in community and not in the core
Not
Spring
in the
AI
core.
project.
Yeah. Yeah. So I think we talked a lot about the building phase, building agents. What are the things that we have available, right? From tools, MCP, RAG. Now, building agents is one thing, but ultimately the goal is to deploy the agents. And as developers, when we talk of deploying an agent, again, the utilities and the production readiness comes into the picture, because we cannot just deploy an agent on something which is not a stable environment, and where observability and security is still not taken care of. So on the lines of that, I was reading about this brand new Spring AI SDK for Bedrock AgentCore, which recently went GA, right?
Yeah.
So I think my perspective on that particular SDK has been that for Java developers, when we are trying to build an agent, we are trying to also expose, let's say, a post mapping of that via a slash, let's say, invocation endpoint, and we are exposing that particular agent. And then for the deployment part of it, in the application properties, there are a bunch of different configurations or resources that we have to add, which again is increasing the total development time of building and then taking it to production. But with the SDK, I read about a very interesting annotation, the @AgentCore invocation, so that under the hood, I believe the auto configuration is happening. So which is going to save a lot of development time for the Java developers. But would love to hear from you, because you have been a contributor of that SDK as well. Would love to hear from you that what does it actually change for the Java developer, apart from reducing the development time? What does it actually change for the Java developers, and how well, or in what best possible way can the developers start using this particular SDK when we are talking of building and deploying production ready AI agents?
Yeah, I mean, we got to run our agents somewhere, and so you can run those wherever you want. Really, it's they're just Java processes in our case, and so AgentCore is a great place to run agents and MCP servers. And if you do want to run your agent and how to do its agent thing and run it on AgentCore, it has to conform to a specific contract, which states which port it listens on, a slash invocations endpoint, as you said, a health check endpoint. And so these things need to be configured. And of course, you can do this all without a library. You can do it with whatever. But we created that Spring AI AgentCore library just to make it super easy to do all the things that conform to AgentCore runtime, so that you can run your agent there. And so, and then there's a bunch of other things in that library that are also interesting. So one of those is AgentCore memory. So as we talked about in this agent architecture, you need a memory component. Memory usually has a short term and a long term. Short term is like every message that went to the LLM and came back from the LLM. And then long term is over time, how do you summarize, how do you pull out the important facts, the important parts of the conversation into long term memory? And so AgentCore memory actually can be used either with your agent running on AgentCore, but can also be used with your agent running elsewhere as well. Like you can just use AgentCore memory totally standalone. Yeah. And so we now have a library in the Spring AI community for doing that AgentCore memory. And then there's a few other features of AgentCore that are also supported in this library. So there's one for browser use, so you can have your agent drive a web browser. And then there's another one for code interpreter, which is like dynamically writing code and interpreting it for like kind of dynamic workflow sorts of scenarios. So that was just announced, brand new and really exciting. That makes it so easy to do the production side of your agents. There's the other side, which we haven't really talked about, which is actually just the inference, like where does my model live and how do I talk to it? And so of course there's the Amazon Bedrock service, which provides 250 different like serverless models essentially. So you can just pay based on tokens that you use to those models. And so this is everything from the Claude models to we have the Amazon models called Nova models, and then tons of other models that are available there. And of course, all that works with Spring AI, and works with Embabel, and works with Koog, and works with really all of the different AI technologies in the JVM space. Have great support for Bedrock for the inference side of things. But that's really like when we get to production, we got to think about, okay, how are we going to scale the inference? How are we going to scale the compute for the agent? How are we going to observe those things? How are we going to, build DevOps and all the abilities? Like, how do we deliver those? And so, yeah, I mean, in the JVM space, we've got really great solutions there. This is our bread and butter, as you said earlier, for what we do as Java developers is build these production enterprise grade systems that need to perform and be secure and reliable and all that stuff. And so, so it's all that, of course, works well on AWS with all the Java AI options.
Yeah, I mean, I am super happy to have that one particular annotation, which is going to save up so many different changes that I had to make in multiple files. So definitely, just as Java main pillar has been always about improving developer productivity, I believe this particular SDK is going to significantly improve the developer productivity, the Java developer productivity, when it comes to actually building and deploying your agent. So yeah, I think really great stuff. Really happy to try it out for the upcoming projects. So James, you just talked about AgentCore memory and two important strategy like the short-term memory and the long-term memory. So when we usually use any kind of code assistance, after some time when the context gets overloaded, I see they say compacting the particular context window. And I also read about the sliding window algorithm is being also used where in the short-term memory up to default like 20 messages in the Spring AI, one of the classes have. So up to 20 messages is what they're going to retain in that particular window. And I believe post that they're going to compact that and maybe move it over to the long-term memory. So how is that thing going to happen when we are trying to build production-ready AI agents? The thing that we want to keep it in the short-term memory and what do we want to keep it in the long-term memory? And I think different strategies for that. So would you like to talk about that?
Yeah, this is definitely one of the more complex spaces of the architecture with agents is if you have a something that needs memory, which most agents do, you have to have some state when you're in that loop. Then how do you decide what's the right state to keep around and what's the right state to get rid of? There's reasons why you want to get rid of things. One, you're going to use tokens for everything all the state that you put into those LLM calls. But then also something may distract the LLM from what's important. And so we have some approaches for how we deal with memory with our agents. And the basic form of this in Spring AI is what you said. It's this windowed memory. And so what we do is per each user, we keep the last 20 messages that have gone to the LLM and back from the LLM. And on every request, we send those last 20 messages. And so that's a very simple approach. But you can imagine as the conversation gets very long, we're potentially rolling off important things that were part of the conversation that need to be preserved. And so this is where then the concept of long-term memory comes in, is how do we take those short-term memories, those individual messages, and turn them into the facts that we need to know about the user, the important summarizations. This thing was decided, this thing was stated. And so how do you take those important things and asynchronously in the background use an LLM to do those summarizations, find the facts, and then integrate those long-term memories in with your short-term memories so that you generally will have both in a different application. So AgentCore does both the short-term and the long-term. There's a similar approach in Spring AI called auto memory or something like that, which is a brand new part of the library in the Spring AI community. And so definitely an evolving space to figure out what the right way to manage memory is. But yeah, it's an essential part of most of these agentic applications and one of the harder parts to get right.
Yeah, and like you rightly mentioned that it's one of the complex pieces of architecture that we are trying to solve with different strategies that we have come up with. And it is something like a non-negotiable when we are trying to architect for an AI agent. It is things that it is in progress. Like we are definitely going to integrate the different memory strategies into our application space, but it is very important for the developers to be mindful about which strategy to use when, rather to take a call on when to use which strategy, because that is going to determine the entire state or the flow of the agent and do the things correctly as it is supposed to do, right? And on the same lines, James, that memory being such an integral part of AI applications, and we also talked about tools, which are more like you're getting the actions done by the agent, and then to externalize it, we're using MCP. We talked about tools, and then we talked about MCP, we talked about memory just now. And there's, of course, we cannot be here and not talk about RAG, so which is providing the domain context, right? And the very basic confusion which nowadays have added onto this is the introduction of the agent skills. So now we have tools, we have tools, We are also talking about MCP. So we have tools, we have MCP. We also have RAG, which is providing the supplementary context or the business domain related context to the agent. Now, when we already have these things, now skills are also helping us to organize the capabilities of the agent. So now with these four different things or maybe complementary things in place, what do you think that as developers, how do we actually put these things together or wire these things together when we are designing the AI agent?
It's a good question. Usually I just ask my AI to help me architect it. It's complex, and that's why architecture and architects, you have to really understand the things that are available in your toolbox that you can use to get to the outcome that you need, and then balance that with what the business ultimately needs. And so that's a lot of the job of what an architect does. And so it does take some thinking to figure out the right way to weave all these things together. So the way that I see it is tools and MCP servers, these are for actions, as you said. These are the things that are going to call business systems, perform updates, those sorts of things, integrate with third parties that already provide MCP servers. Skills are for providing some knowledge to the agent. And so this is knowledge that you want to kind of create some gravity around in the inference call. And so with skills, if there's something very particular to your business domain that you really want to like maybe the LLM knows about it, it's just like maybe it's going to have a hard time recalling it against all of the general knowledge. Whereas if you put in a skill, then that says, hey, this is important. Focus on this kind of construct. And so knowledge is great for skills. And with skills, like we talked about with MCP, there's usually a progressive discovery of the skills. And so that's how we save on tokens, is to not just give it all the skills all the time. We let the LLM decide when it wants to actually use a skill, and then that pulls into context. And so we can do that progressive discovery with skills. With RAG, the way that I see RAG is that it's when me as the architect or developer wants to make a decision about what data should be included in my call to the LLM. In the case of tools, the LLM is deciding when to make that call and say, okay, now I need this data.
Yeah.
But if I know that, like, let's say I'm writing a banking chat bot, I know that almost 100% of the time that somebody's going to ask about their account. And so I'm going to include in the prompt automatically every time, maybe not every single time, but semantically the user has asked something about their account. I'm just going to include it, because then I don't have to wait for the LLM to reason and then decide to do a tool call to go get the account information. I'm just going to include it. And so usually with RAG, you've got a semantic search that is searching based on the user prompt and data that's available, and then deciding to put that stuff into the prompt. And so that's our general approach with RAG. And it definitely is one of the tools in the toolbox that we as builders and developers and architects have to figure out when and how to use in the right way while maintaining data security and all those things.
Yeah, it's very interesting to look at that. There's a what versus the how. So when we are saying what it should do, if I am an architect, I'm going to have it through RAG. Okay, this is how you should be, or rather, this is what you should be doing, or via the tools, the agent itself can take an action. So that is about the tools and the RAG. But I think when we are applying or giving the skills as like the markdown files, it's more about how the agent should be processing that particular ask or the prompt that has been. So it is essentially between that. But then you also mentioned that knowledge is something the skills are providing with the help of the markdown files. And when we have been playing around with RAG, knowledge bases like we have, so knowledge has also been a core terminology that we are supplying with RAG. So now my question to you is, as a developer, it's far easier for me to write a markdown file and give it to the application in the form of a skill. But then RAG takes a completely different approach of chunking, embedding, search, and all of that. Yeah. So then as an architect, how do I know, like, when should I use RAG, particularly what scenarios, and when should I use skills rather, or maybe an amalgamation of both of these?
Yeah, it's a good question. I think they are similar in some ways. The way that I look at them differing is that skills are really about like almost documents. Like it's things that like you said, markdown, like it's something that can be represented in a document. These can be instructional. So a lot of time we have something in the Amazon space called SOPs, and SOPs, standard operating procedures, right? And so you can encode that information around the standard operating procedure into Markdown and give that to the LLM. Like it's a document. It's giving some instructions. It's giving some additional knowledge. And so that to me goes in skills. If on the other side, and likely you need all these things for something real, if you have data that you want to sometimes insert into the context to go to the LLM, and you want to make that decision, not the LLM, not wait for the LLM to decide it, then that's when you use RAG. But it's really about like data that's coming from a database, likely, and that's where you're going to apply RAG.
Yeah, yeah, very, very interesting. I think it's up to the architect, and it's of course up to the business context that we are trying to solve. And also, this one thing which comes to my mind, that I was trying out a certain project with the skills, where in the class path I included that particular skill, and the agent almost picked it up while I tried to wire it through. But if there is a way, I'm not sure if there's a way in which something like a Maven dependency, if we can import the skills into the projects, it would be easier for me to actually, of course, as dependencies, if you can add it into the project, it would be far more convenient. So do we have any mechanism for that?
Yeah, so I created something called skills jars to do exactly this. And skills jars is this idea that you should be able to take your skills, these documents, and package them up into standard dependencies that we put on Maven Central or Nexus or Artifactory server, and then we can version it, which means it's easier to validate. Okay, I made sure that version 1.0 was went through a security scanner and has the right licensing, and you can do all these kinds of checks and validations around these things once you have them as actual dependencies that are in the same form as the rest of the dependencies in our system.
Okay.
And so skills jars just creates the tooling and the format for how you should do skills inside of jars. And now there's a website where you can go deploy new skills jars if you want, and see what skills jars other people have deployed. And so that's the good way to do kind of dependency management for skills. You can do like transitive dependencies. So you can have a skill jar that depends on other skills jars, and so that's a nice thing with using a dependency manager for this. Is the
I really like the name of the skillsjars.com, right? So it's like the dependency management for skills. It's really, really absolutely amazing. And the point that you also mentioned about the security scanning being done, because that is also one thing which as developers we have in our mind. I remember in engineering, a lot of development time had been spent while trying to fix the CVEs. So security vulnerabilities are always a thing. So now that we are trying to import skills as dependencies into our project, the last thing I would want to do is to fix the security vulnerabilities of particular skills that we are importing. So that's a truly game changer thing that you're doing as part of the skills jar by adding in the security scanning as well. And now, talking of security, now that our AI agents are autonomous or semi-autonomous, doing all the things, reasoning, planning, acting, taking actions, all of that is great. How much trust can we actually have in the AI agent? Because in terms of security, how can I actually be, of course, I cannot be 100% confident about what the agent is trying to do, but there is this concept about HITL, or human in the loop. So what do you think that when we are talking of security, where does human in the loop actually come into picture, and where does things like evaluators and observability and guardrails are also coming into picture? Because all of this together is like a suite of things, like so many different things, but kind of complementing each other. But this being absolutely non-negotiable when you are actually deploying your agent, because like I said, building is one thing, you have to deploy it somewhere, and when you're deploying, all of these concerns are anyway going to come into place. So where does humans have a role to play, and where do we actually have the evaluators, observability, and guardrails? Where do they come in?
So there's more pieces than we've gone through. We've gone through a lot of the pieces of the general kind of AI agent architecture, but as you said, there's a few others. So human in the loop is when you want to have the human verify or add some additional information before continuing. And so there's multiple ways to do that. We at AWS contributed the elicitations feature to MCP, which is doing human in the loop for MCP. So essentially you can have an MCP tool that tool call comes in from the LLM, but then based on some logic in the tool call, it decides, oh, I need some more information from the user. And so then it kind of halts there and then asks the user to ask the agent to ask the user this thing, and then the user can input what's needed, and then that gets sent back to the MCP server, and then the MCP server tool call can continue moving forward. And so so that's one way to do human in the loop, and there's a number of others as well, depending on like where and how your agent runs and how you want to interject the human in the loop pieces and all that. So that's another important piece. You mentioned what was the next one? Observability.
Observability, evals, guardrails.
Yeah, so with observability, luckily in the Java ecosystem, we've been pretty big supporters of doing observability, and so this stuff is all supported. And no matter what you're doing in the world of Java, there's great observability for the whole agentic system. And I think there's even now a library called Tracy.
Yes.
Yeah, which does like essentially distributed tracing for agentic systems. That's from JetBrains, and so yeah, so many things in that space. I think like we're well covered at this point on observability. The piece that is still kind of emerging is what you mentioned about evals. So with these non-deterministic systems that we have with LLMs, it does become harder to test them and to do integration tests. And so there's approaches that have emerged and are still evolving on how to do this. Evals is the primary one, and there's kind of different subsets of evals and different frameworks for doing evals. But essentially an eval is a way to take a piece of your agentic flow and have it do something, and then typically the way that you then evaluate whether it did what you wanted to or not is you actually take the result, you give it to the LLM, potentially even another LLM, because maybe if you use the same LLM for your agent and for judging the agent's output, maybe you're not going to get the best result. And so you take the output, give it to an LLM, and then you give it some criteria about what success looks like. And so, Spring in Spring AI community has an eval way to do evals with Spring AI. There's many other options out there.
I think I had tried out something like the fact-checking evaluator and also the relevance evaluator. And very interesting thing when you said one agent going to evaluate the results of another LLM. I think there was some really funny thing that they're going to they just mentioned in the prompt that, hey, you're supposed to do this. Whatever results you're going to get, I'm going to get it evaluated by XX, some other model. So that was really fun. So it was like more like introducing some sort of the competition, that this is the result that you're going to give me, I'm also getting it evaluated by another model. It's not always the another model, it can also be sometimes same model also. Like I was just trying out in Spring AI when the fact checking evaluator, the output was plugged into the prompt of the same model itself, and then it evaluated the thing. So I think that is very interesting and a progressive space that we are in, right, around the evaluators that we are talking about in the observability space.
Yeah. And then the other one you mentioned was guardrails. And so guardrails, there's different ways to do guardrails. In the case of Bedrock, we have the ability to provide multiple ways to do guardrails. But guardrails is just kind of trying to put, as it says, guardrails around what the LLM can do. Like you've probably seen funny memes like, oh, I used the Chipotle chatbot to have it do my homework or write some code for me or whatever. And I don't know if that was real or not, but it's like you generally, if you're putting a agent out there on the internet, people may find ways to abuse it. And so having guardrails can be one way that you can try to tackle the potential abuses or unintended uses of what you've done. And so like the Bedrock guardrails are, have a lot of different ways that you can manage that. So all things that now Java developers becoming these AI agent architects need to think about all these pieces. And, just like any, real system, there's a lot of pieces to think about and a lot of things to consider and a lot of different approaches for how you fit everything together. And so time to get up to speed.
Yeah, definitely. So Java developers, Spring Boot developers, please take a note of it, that whatever you need to become, like whatever you need to create a production ready AI agents, all the LETs and everything has been taken care of. You already have the libraries and the frameworks. Now it is the matter about getting up to speed, like you said, having an awareness of what exists, and of course taking the right decision about what to use and when to use, and of course why to use it. So I think that is very important for the developers. And very important thing is we already have the comprehensive suite of things already available to us. It is all about choosing the right tool to do the right thing. So this is really amazing that we are already kind of sorted in that space.
Yeah, it's a great time to be a Java developer. And
yes.
It's been super fun. I'm having a blast writing code and building my agents, and I've got agents I've built in Spring and MCP servers I've built in Spring and things I've built in Kotlin and Scala, and I'm really enjoying building these AI things right now. So hope others find that joy as well. It's a fun time to be a Java developer.
I think we have covered a lot about where we were, where we started from, and now that we are in the world of agents and deep down into the architectural level, I think because as Java developers, we don't always like to have a working code up and running in minutes. It's more about taking time, understanding the abstractions, understanding the architectural decisions. And I think I recently did a video on my channel where I said Java developers love patterns, whether it is enterprise integration patterns or design patterns or anti patterns. So I think when we talk of patterns, it's always about the enterprise AI integration as well. Now, I just want to ask you that I'd got a question from a community. It's a question around the trade-off that we have. That we have Spring AI, like you mentioned, that if you're a Spring developer, Spring AI is your closest framework, and if you're into Quarkus, LangChain 4j is also there. So then the concern among the communities who have not yet got up to speed with the integration is, when should they use these frameworks, or can they use these frameworks together, or there is a particular affinity which they should have to a certain framework, again grounding in their business context or their problem enterprise context that they are working in. So what are your thoughts about the things that developers need to keep in mind when choosing between not just Spring AI and LangChain 4j, but between this entire vast ecosystem of frameworks and libraries, which we also discussed on the AI for JVM? So quite a few of them, but how do we actually choose, going beyond your natural tech stack
Yeah.
thing?
Yeah, I mean, I think like we said earlier, the most important thing is probably like what are you most familiar with. But there are of course other factors as well. Embabel, I think is I've said earlier probably the most advanced agent framework on the planet. Like Rod has really rethought a lot of the foundations of building agents, and so yeah, I think there's great stuff there. And so I think the most important thing in this space is that pick one, go deep on it, because the concepts are actually very transferable. Mm-hmm. And so let's say you decide that LangChain 4j is going to be where you start. Great, like start there, learn the architectural paradigms and approaches, learn tool calling and RAG, learn inference caching, learn structured outputs, learn so there's even more things we haven't even talked about in this whole space.
Yeah.
Learn RAG, learn skills, learn observability, like learn the architectural approaches, because those will be transferable to other things. There may be different ways that these different systems do RAG, for instance, but conceptually the architectures look very similar no matter which of these abstractions you're using. And so yeah, just to like pick one and start building something. Use an AI to help you build something. Like build it now, because like now is the time to get up to speed and start learning how to build these next generation architectures, because no matter how we feel about AI, like it's here to stay, and it's providing real value in a lot of different ways. And so let's be the ones that build the future of AI, and especially for the enterprise. And start getting up to speed.
Yeah, like very, very nicely you have summarized. I think one important thing is most of the things that you are learning and building, the skills are actually transferable. So instead of stressing upon what to use, which tool to use, or which framework to use, pick one, get started, go deeper into it. Once you actually understand all the concepts of that particular framework, you can easily apply it to any other framework of your choice or of your need that you have. That is very important thing that you mentioned. And of course, the best time to be a developer, to best time to become and remain a Java developer is of course today. And very important thing that you mentioned is building the future of AI, being a Java developer. Again, this is an amazing time to be in. So I believe that with today's podcast with James, the Java developers who have been so frantic about what they're going to do with such a vast ecosystem and so many things to catch up on, they're going to have most of the questions answered. We started about where we were and now where we are and where we should be heading 2026 and beyond. So I hope this would have given you enough clarity about what you should be doing next. And as I always say that writing code has always been the easy part of software engineering, right? The hard part has always been about keeping the code running for the long term, for the long run. And that is where, as enterprise Java developers, we have that edge, this unique natural edge over other developers, that we have been very much embroiled into this system where we have been working on keeping things running for decades, right? So I think the more and more we get into all the developments that we are seeing in the AI space and choosing the right tools and the right things to do, I think the better we can build the future of AI with Java developers. So yes, all the developers out there, Java, JVM developers, there's no need to unlearn Java. There's no need to relearn Python, right? James is here to validate that statement, of course, and just stick to what has been your core strength, and just start building. I think the best time to build it was, I think, 20 years back, and the best time to build is again now. So thank you, James, so much for your time and for coming over, for doing this amazing, such a long podcast. I'm sure our developers, our viewers are going to get a lot of value out of it. So thank you so much for coming for this podcast. Really, really appreciate all the questions that you have answered. Thank you so much, James.
Thanks for having me.
And with that, thank you so much for watching this video. And do let me know in the comments below if you have any other questions or any concerns and what do you want to watch in the next video. And thank you so much and see you again in the next one.